important, and it is known as the variation graph of spectral distribution with the beam intensity. Now, moving on to measurement. Now, once the solar radiation comes to the Earth's surface, we need to measure it also, and there should be certain instruments which can measure the beam radiation and also the diffuse radiation, or sometimes measure the total, that is the insolation. So, why this measurement is very important? Because once we know that how much of radiation is coming at a particular place, this is very much needed for design engineers to design certain solar collectors that need to be placed at that particular location longitude. So there are two basic type of instruments. The names are very important: a pyrheliometer and a pyranometer. So a pyrheliometer is an instrument which collimates the radiation to determine the beam intensity, and the pyranometer is something that measures the total solar radiation. But however, what we use is that the pyranometer is the most commonly used because we can measure the total radiation or insolation at a particular place. Now, coming to the pyrheliometer, which is mostly used, and that is known as the angstrom compensation pyrheliometer. So, this is the schematic, and in this type of pyrheliometer, there is a thin blackened shaded manganese strip of size 20 into 2 into 0.1 mm. So, this is the shaded strip, and it is heated electrically. As we can see, this is heated electrically until it becomes at the same temperature as a similar strip which is exposed to the solar radiation. So this is the figure, and there is a thermojunction of the galvanometer. This is the measurement of the current, and these are the keys. So in this way, this is a shaded strip, and this is the exposed strip that is exposed to the solar radiation. And under steady state conditions, when both the strips are at identical temperature, the energy used for heating the shaded strip is equal to the absorbed solar energy. The thermocouples are there at the back of each strip, connected in opposition through a sensitive galvanometer or null detector, which are used to test for the equality of temperature. That when the temperature becomes equal, then the energy H of direct radiation is calculated in this manner. That is K I square. I is the current and K is a constant. And this is the concept of a pyranometer. So a pyranometer is a radiation energy measuring device which is designed to measure the global radiation or the total radiation, usually on a horizontal plane, but it can also measure the same radiation on an inclined plane. And this is a shading ring that is there. So the shading ring actually prevents the beam radiation reaching to the detector. And the pyranometer at this condition, if the shading ring is given, it can only measure the diffuse radiation, and it consists of a thermopile. Thermopile is a series of thermocouples and whose sensitive surfaces form the hot junction. This surface is black and circular in shape and exposed to the radiation, so that the surface should respond to the radiation of all wavelengths and absorb it as a black body. The temperature of the hot junction increases depending upon the incident radiation absorbed by it, and the cold junction of the thermopiles are completely shaded to prevent the radiation reaching. So it is shown as a white color and black color. And the sensing element is covered by two concentric hemispherical glass domes to shield it from wind and rain. And this also helps reduce the air inflow to the detector. So, by the concept of this thermopile, and by looking at this white junction and the black junction and the temperature difference, we can measure a particular radiation at a particular place on the Earth's surface. So these are the two broad classification of pyrheliometer and pyranometer, which are basically the solar radiation measurement devices. Now, moving on to the classification of solar collectors. Now, we have known about solar radiation. We have also known about how to measure solar radiation, but we need to know about certain devices that can collect solar energy, and these are known as the solar collector. And this classification is very, very important for the exam purpose for the students. So, what is a solar collector? By definition, it is a device that collects and absorbs the solar radiation, and it also transfers the absorbed heat energy to a fluid. It may be liquid, it may be air, depending upon that the classification is done. And also there are about two major types. One is the non-concentrating on the flat plate, and another is the concentrating type. So this classification is very important. The broad classification is the non-concentrating type or the flat plate and the concentrating type. And the concentrating type is also divided into two parts, that is the focusing type and the non-focusing type. The focusing type is again divided into two parts, that is the line collector or line focus collector and the point focus collector. Line focus collector is divided into the cylindrical parabolic, the fixed Miller solar, and the linear Fresnel lens collector, while the point focus is divided into the paraboloidal, circular Fresnel lens collector, and the classification comes to the hemispherical bowl concentrator and the central power receiver, while the non-focusing type is divided into the modified flat plate collector and CPC, that is the compound parabolic concentrating type collector. So this classification comes as a 5 marks question, which is important for the exam purpose. Now moving on to the concept of the solar collector, that is a flat plate collector. So as we can see that this flat plate collector is actually a collector device that transfers the heat energy into a liquid in contact with it. So it's a flat plate typical liquid collector, and we need to know how it is constructed and what is the principle of operation. So as we can see that there are many types of flat plate collectors, but this flat plate collector is known as the flat plate tube type collector, the plate and the tube type collector, as we can see. So there are several tubes and plates. So it is basically consisting of a flat surface with high absorbivity for solar radiation, known as the absorber or the absorbing surface. Typically a metal plate, usually made of copper, steel or aluminum material with tubing of copper in thermal contact with the plates, is actually taken as the most common of the used materials. The absorber plate is made of a metal sheet 1 to 2 millimeter in thickness, while the tubes, which are also of metal, these are the tubes. They range in dia from 1 to 1.5 centimeter. And these tubes are basically soldered or braced or clamped to the bottom, and in some cases to the top also of the absorber plate, with a pitch size ranging from 5 to 15 centimeter. In some designs, the tubes are also line and integral to the absorber plate. So what we do is that it's a transparent cover. So these are the diffuse radiation, this is the beam radiation, and there is a cushion and support seats for the glass cover. There should be a cover for the collector. Then we have the absorber plate, then we have the tubes where the liquid is flowing, and we also have an insulation to reduce any amount of heat transfer. So the insulation is provided so that whatever the solar radiation heat is trapped, the major amount can be transferred to the liquid or the fluid that are flowing through these tubes or pipes. And this is another important thing, that is the difference between the flat plate collectors or the non-focusing type collectors and the focusing type collectors. So what are the differences? We go one by one. First of all, for the flat plate collector, the absorber area is large and small. The concentration ratio is 1, while the concentration ratio for the focusing type collectors is very high. So we use the focusing type collectors mostly. So its concentration ratio is very high, ranging from 4 to 3000. The temperature range is low, not more than 70 degree, and as the concentration ratio is directly proportional to temperature, so the focusing collectors can have a high temperature range of about 3000 degrees Celsius. The flat plate collectors can measure both beam and diffuse radiation. They can use both the radiations, while the focusing type collectors they mainly use beam radiation. The flat plate collectors are simple in construction. The tracking system is not required. Maintenance is less. But the focusing type collectors, as we know, they are complicated in design and difficult in maintenance. Also, tracking system is required. So we need to have a compromise between the temperature and the maintenance thing. As the concentration, as the construction and the concentration ratio is less, so it's less costly and it's more costly. Application is limited to areas where the temperature requirement is low. High temperature applications such as power generation is needed for the focusing collectors, and it is suitable to place at all places, and it can work mostly in clear or cloudy days. But for the focusing type collectors, they can work mainly on days where the weather is clear, because it's dependent upon the measurement of the beam radiation. So this with this we conclude the concept of about the collectors, then the classification of collectors, then radiation, the measurement of solar radiation, and we continue with the next part where we discuss more about the different other aspects of solar energy. So thank you students, thank you for listening.